Hi, Assalamualaikum and have a good day to Dr. Rafida binti Ali. Welcome to our presentation, which is from Group 2. First of all, let me start by introducing myself and my group members. My name is Nur Farah Izzati binti Muhammad Fadil and my members are Nur Fatin Shahira binti Seliman, Nur Rafiza binti Abdul Aziz, Farah Shikin binti Muhammad Effendi, and Farah Natasha binti Nordin. As you can see on the screen, we will present our group project assessment on the subject of JGB32303 Operational Research. So, we will be covering these three project topics, which first is transportation problem, second is project management, and last but not least is linear programming.
Next, I will explain about the transportation problem. The transportation problem is a special type of linear programming problem where the objective consists of minimizing transportation costs of a given community from a number of sources or origins such as factory or manufacturing facility to a number of destinations such as warehouse or store. Each source has a limited supply, which is the maximum number of product that can be sent from it, while each destination has a demand to be satisfied, which is the minimum number of products that need to be shipped to it. The cost of shipping from a source to a destination is directly proportional to the number of units shipped.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farah Natasha binti Nordin, so I will present about the transportation problem. The question for the transportation problem given by the following table, find an initial basic feasible solution by the northwest corner method and then find an optimal solution. The supply at source 3 is now reduced from 10 to 6. There is a penalty of 5 for each unit required but not supplied. Find the new optimal solution. Before I continue, the objective of the transportation model is basically to minimize the total transportation and production costs from several points of supply called sources to several points of demand called destinations. A table is first set up with rows, a supply and the columns to represent demand. The value in the small square in each cell indicates the cost of shipping one unit of product from the source to the destination. A simple way to find the initial solution is by northwest corner rule. The starting point is the northwest corner of the table with the maximum quantity allocated to the cell. If the supply at each row is allocated fully, allocation is then moved to the next row. This begins with the first row. Similarly, if the demand of each column is allocated fully, the demand is then moved to the next column, again beginning with the first column. Finally, all the supplies and demands are ensured to be satisfied. Below is the solutions step by step to complete initial solution using the northwest corner rule. Overall, all supply equals to or more than 0, so this is optimal. Solution is not unique, but optimal cost is. So the total of minimum cost is equal to 243. Now with supply at source 3 reduced to 6, at dummy row with supply equals to 4. If we take the previous optimal solution, reduce x35 from 5 to 1, put x45 equals to 4, and let demand 4 equals to negative 10, we find that the resulting table is still optimal. The cost is now equals to 223.
In conclusion, the transportation problem represents a particular type of linear programming problem used for allocating resources in optimal way. It is highly useful tool for managers and supply chain engineers for optimizing costs. The IPSolve-R package allows to solve LP transportation problem with just a few lines of codes. While there are other free optimization software out there, such as Games, MPL, Tora, and Lindo, having stored an LP transportation problem or code in your personal code library could save you a significant amount of time by not having to write the formulation from scratch, but instead of by only having to change the coefficient and signs of the corresponding matrix.
In this section, I will present a project management network diagram. A project network diagram, also known as a project schedule network diagram or a pre-Gantt diagram, is a graphical representation of the activities and their relationships in a project. It illustrates the logical flow and dependencies between various project tasks and helps in visualizing the project schedule. The network diagram typically consists of nodes representing the project activities and arrows or lines representing the dependencies or relationships between the activities. The activities are represented as rectangles or circles, and the arrows show the sequence in which the activities should be executed. So now we move to the benefits of the project management. So the project management offers several benefits to project managers and teams. So here are some of the key advantages, which is, first one is activity sequencing. The network diagram helps in determining the proper sequence of activities by illustrating the dependencies between them. It allows project managers to identify which activities must be completed before others can begin, enabling effective planning and scheduling. The second one is critical path identification, which the network diagram helps in identifying the critical path of the project. By identifying the critical path, project managers can focus their efforts on managing and optimizing these activities to ensure timely project delivery. Next is time and schedule management. By considering these dependencies and duration of activities, project manager can create a well-structured schedule that accounts for all project constraints. Last but not least, performance tracking. The network diagram can be used as a baseline for tracking and monitoring project progress. By comparing the actual progress against the planned schedule depicted in the diagram, project managers can identify any deviations and take corrective action promptly. Overall, the project management network diagram is a valuable tool for project planning, scheduling, and control. It aids in understanding project complexities, optimizing resource allocation, and ensuring timely project completion while considering dependencies and potential risks. So this is the question that we need to determine the critical path of this network diagram, and we need to find out the earlier start, earlier finish, latest start, and latest finish time for this network diagram. Now we move to the critical path. The first path for this network diagram is AEDFIG, which the time is 32 weeks. For the second path is AEDH, which is the time is 30 weeks. And the third path is BEDFIG, which the time is 27 weeks. For the fourth path is BEDH, and the time is 25 weeks. Last but not least, the fifth path is CIG, which the time is 20 weeks. Since the maximum time is 32 weeks, therefore, critical path is AEDFIG. Now we move to early start, earlier finish, latest start, and latest finish. So for your information, the earliest start of an activity is the earliest possible time an activity can start. The earlier finish time is the earliest time an activity can possibly end. This is estimated by adding the earlier start time of the activity and the activity time. The latest start is the latest time an activity can start, while the latest finish is the latest time an activity can finish without delaying the project. A backward pass is used to estimate the latest finish time and the latest start. The latest start time is calculated using the relationship latest start equal to latest finish minus activity time. This lag, also known as total float, which is the difference between the later start and the earlier start, or difference between the latest finish and the earlier finish. So the earlier start of activity A is 0 and the earlier finish is 7, which 0 plus 7 equal to 7. Where we get the 7 is from the activity time of A. In the same way, the earliest start time of activity B is 0 and the earliest finish time is 2. Same goes how to find activity A. Since activity E can only start when both activity A and B are completed, the earlier start of activity E is 7, which the largest of the finish time of A and B. In the same way, the earliest start of activity I is 27, which is the largest value of 27 and 50, which is from activity F and C. So to find earliest start and earliest finish, we need to start to find out the earliest and earliest finish from left to right. And we can find out for latest start and latest finish from right to the left. That is the rules to find out the latest start, latest finish, and latest start and latest finish. So to find the earliest start, we need to add in earliest start and activity time. But to find the latest start is we need to minus activity time with latest finish, or latest finish minus activity time. So since the slats of activities A, E, D, F, I, and G are all 0, these activities lie on the critical path. These activities cannot be delayed, as any delay will affect the project completion time. So the project completion time is 32 weeks. Those critical paths are determined by identifying the activities with 0 slats. In conclusion, a project management network diagram is a valuable tool for project managers and teams. It provides a visual representation of a project activities and their dependencies, allowing for effective planning, scheduling, and coordination. By using the network diagram, project managers can identify the critical path, allocate resources efficiently, estimate project schedules accurately, assess risks, and track project progress. It enhances communication among stakeholders, facilitates decision making, and enables proactive management of project constraints. Overall, the project management network diagram is an essential component in successfully managing projects and ensuring timely and successful project completion.
Assalamualaikum. My name is Nurhatin Syairah binti Suliman. I will present the question number 3, which is in topic linear programming. Topic introduction. A linear programming is a mathematical optimization technique used to solve problems where the goal is to find the best outcome in a linear mathematical model subject to constraint. Example of linear programming problem is a product mix problem, a blending problem, a production scheduling problem, a transportation problem, and the last one is a flow capacity problem. This is the question number 3. A dietitian wishes to mix together two kinds of food X and Y in such a way that the mixture contains at least 10 units of the vitamin A, 12 units of vitamin B, and 8 units of vitamin C. The vitamin content of 1 kg food are given below, as we can see in that table. Okay, 1 kg of food X costs 16 ringgit and 1 kg of food Y costs 20 ringgit. Find the least cost of the mixture which will produce the required diet. Okay, this is the answer for the question number 3. The objective function is 1 kg of food X is 16 ringgit and 1 kg of food Y is 20 ringgit. So from that, we cut the maximized X, which is 16X plus 20Y. And from that table, we cut the subject to constraint. And the first subject to constraint is X plus 2Y more than 10. And next, X plus Y more than 6. 3X plus 4 more than 8. And X more than 0 and Y more than 0. Before we make the graphical solution, we have to find the intercept x-axis and y-axis. To find intercept x-axis, we have to make the y to 0, and when to find the intercept y-axis, we have to change the x to 0. So, for the first subject to constraint, which is x plus 2y more than 10, the x we got is 10, so the answer is 10, 0. And for the y-axis, we got the y 5, so the answer is 0, 5. And next subject to constraint, x plus y more than 6, we got the x is 6, so the answer is 0. And for the y-axis, we cut the y is 6, and the answer is 0, 6. 3x plus y more than 8. Intercept x-axis, we cut the x is 2.67, so the answer is 2.670. And for the y-axis, we got the y is 8, so the answer is 0, 8. We create the graphical solution to linear programming problem from the intercept axis x and axis y, and we cut the corner point from the subject to constraint.
Hi, my name is Farah again, and I'm going to present about the interception. So the first equation for the interception is x plus y is more than or equal to 6. And the second equation is 3x plus y is more than or equal to 8. So we multiply the equation x plus y equal to or more than 6 to 3 to ease the substitution process, and we got y equal to 5, and when y equal to 5, x is equal to 1. So the second interception is between the equation x plus 2y is more than or equal to 10, and the second equation is x plus y is more than or equal to 6. So we multiply the equation x plus y equal to or more than 6 with 2 to ease the process of substitution, and we get x equal to 2. When x equal to 2, y is equal to 4. Next, we are required to calculate the corner point. The objective is z equal to 16x plus 20y. The corner point is 0, 0. The second corner point is 8 over 3 and 8. The third corner point is 1 and 5. And the fourth corner point is 2 and 4. And the last corner point is 6 and 6. So since the corner point 2, 4 give the least cost, which is $112, therefore this is the optimal solution for this problem. In conclusion, linear programming is heavily used in microeconomics and company management, and then it is used to find the maximum profit for a certain production. And lastly, the linear programming is used for obtaining the most optimal solution for a problem with given constraint.
I sincerely appreciate your attention, and that brings us to the end. I'd like to thank you so much for your interest, time, and attention. Assalamualaikum, and have a good day.